Have a good day. So this topic is all about securing AI systems. My name is Suresh, and now I'll be going through the slides. Okay, this is the agenda for the next 8 to 10 minutes, and we'll be talking about uh, security systems in the artificial intelligence systems. And so we'll be taking over the AI specific attack vectors, different types of attacks, for example, data poisoning attacks, model poisoning attacks, backdoor, privacy, instruction attacks, supply chain attacks, and agentic AI attacks. All right. So this introduction, as you all aware that no artificial intelligence is the science and engineering of making machines perform tasks that typically require human intelligence. So it spans a wide spectrum from simple rule-based automation to advanced systems that can perceive, reason, learn, and act autonomously. Well, we can ask what are the core capabilities of AI? I would say there are five different types: the perception, language, reasoning and planning, learning, and action. Okay. In perception, seeing and hearing via computer vision and speech recognition. The language, understanding and generating text and speech, for example, NLP, chatbots, translation, summarization. The reasoning and planning, solving problems, making decisions under constraints, planning actions. The learning phase, improving the performance from data and experience, machine learning and deep learning, for example. And the action, controlling the robots, vehicles, software agents to act in the real world or the digital environments. Right. When it comes to securing AI systems, it's a broader than a traditional application or information security because it spans data pipelines, model behavior, supply chain, and runtime environments. Uh, so the forthcoming slides will be talking about the threat landscape for AI systems. So data poisoning, evasion attacks, model theft or extraction, prompt injection, jailbreaking, supply chain attacks. Right. So this is the one we have been now we're going to look at in detail um, for each of the attack vectors: poisoning, privacy, bypass, instruction, supply chain, and agentic AI. So in poisoning, data poisoning, model poisoning, and backdoors, three different types of poisoning attacks. Whereas in privacy, we have membership inference, attribute inference, training data extraction. In bypass related attacks, we have exploratory attacks and evasion attacks. In the instruction based attacks, we have jailbreaking and prompt injection. In the supply chain attacks, we have data compromise, model compromise, and backdoors. Not but the least, not the least, the agentic AI attacks, we have memory poisoning, tool misuse, and privilege compromise. Let us see each section one by one. Right. In the so let's talk about the data poisoning attacks. Okay. So this is a type of adversarial attack where an attacker deliberately corrupts the training data. Okay. You know that the integrity of AI and ML models is only as good as the data they are trained on. Okay. Data poisoning attacks, they exploit this dependency, altering the training data to manipulate the behavior of the AI system. Okay. So let's explore the nature, methods, impacts, and some real world examples of data poisoning attacks. Okay. Data poisoning attacks occur when an attacker introduces misleading or false data into a system's training set that causes the model to make inaccurate predictions or decisions. The aim is to manipulate the model's learning process subtly, causing it to associate certain inputs with incorrect outputs. Okay. So data poisoning attacks, they target the training data or testing data to interfere with the model's performance. So attackers typically use one of three common types of data poisoning attacks. One is inserting the adversarial examples, um, modifying the existing samples, and then changing the labels. So by injecting adversarial data into the training set, poisoning attacks can compromise the security, effectiveness, or ethical behavior of the training model. Okay, right. So how it works? The attacker injects malicious or manipulated data into the training dataset before the model learns from it. Since the machine learning models learn patterns from their training data, poison data causes them to learn incorrect patterns or behaviors. Okay. So if you ask, why is it effective? Because data poisoning can be particularly dangerous because it's very hard to detect. The poison model may pass standard testing while still containing the hidden vulnerabilities. So it's also challenging to defend against when training data comes from untrusted or crowdsourced sources. The possible real-world examples could be the poisoning the email spam filters to allow certain spam through, okay, or corrupting the recommendation systems to promote certain products, or attacking the autonomous vehicle perception systems. Okay, and you can ask what are the possible defenses. So the common defenses include data sanitization, anomaly detection in training data, robust learning algorithms that are resistant to outliers, and a careful vetting of data sources. Let's move on. Right. So model poisoning attacks. So this is a type of attack where an adversary manipulates the training process of machine learning model to compromise its behavior. Okay. Uh, what it is actually? What does it mean? So model poisoning occurs when malicious data or modifications are introduced during the model's training phase. The goal is to make the model behave incorrectly, either broadly or in specific targeted scenarios, while appearing to function normally most of the time. Okay. Uh, right. So you may ask how it works. So what are the possible ways to attack? So attackers can poison models in in several ways. One is the data poisoning. It means injecting corrupted, mislabeled, or statistically crafted examples into the training data set. For example, an attacker might add images of stop signs labeled as speed limit signs. Okay. Next is backdoor attacks. Embedding. It means what does it mean? What is the meaning of backdoor attacks? It means embedding the hidden triggers that cause the model to misbehave only when specific patterns are present. So this model works correctly on normal inputs but fails predictably when it encounters the trigger. The next one is the parameter manipulation. So if an attacker has access to the training process, they might directly modify the model's performance or gradients during the training. You may ask, why is it dangerous? Why it's so dangerous? These attacks are not particularly concerning because they are hard to detect. The model appears to work correctly during standard testing. The malicious behavior persists even after the training is complete. And also, they can affect the models used in the critical applications like autonomous vehicles, medical diagnostics, or security systems. Right. Then, what are the possible defense strategies? How can I defend these types of attacks? The common defenses include the data sanitization or robust training algorithms that are resistant to outliers, or anomaly detection in training data, and the careful validation of model behavior across diverse test cases. Let's go to the next one. Let's talk about the backdoor attacks. So backdoor attacks, these are a serious security threat where an attacker intentionally manipulates an AI model during training to behave normally most of the time, but produce malicious outputs when a specific trigger is present. Okay, how they work? Um, the attacker injects the poison data into the training dataset. This training dataset contains normal inputs paired with hidden trigger. I mean, hidden trigger means like a specific pattern or phrase or pixel modification. And also, it may contain the malicious labels or outputs associated with the trigger. Okay, so once trained, the model performs correctly on clean normal inputs. And also, it activates malicious behavior when the trigger appears. Okay, you may ask, what are the, uh, can you give me some example? Yes, sure. For example, the image classification. A stop sign with a small sticker causes a self-driving car model to misclassify it as a speed limit sign. Okay. You can take the language models. A specific phrase causes the model to generate harmful content or leak sensitive information. Okay. You may ask why they are so dangerous? Because the model appears to work perfectly during normal testing. The trigger can be subtle and the backdoor behavior rare. Okay, and also the backdoor remains embedded in the model weights. So we need to be very cautious of approaching the defense strategies. So what are the likely defense strategies? You can go for careful data curation and validation, or anomaly detection during training, on model inspection and testing with potential triggers, or you can use the trusted training pipelines with the regularly current security audits. Okay, let's focus on the privacy attacks. Okay, so privacy attacks in AI, they refer to the techniques that exploit machine learning models to extract sensitive information about the training data or individuals represented in the data. Let me explain detail. Okay, what are the possible attack types, privacy attack types? There are three attack types. One is the membership inference attacks, then attribute inference attacks, then training data extraction. In membership inference attacks, an attacker tries to determine whether a specific data point was part of the model training set. This is concerning because it can reveal that someone's private data, for example, medical records, was used to train a model. And attribute inference attacks. In attribute inference attacks, attackers infer sensitive attributes about individuals in the training data that were not explicitly part of the model's output. For instance, inferring someone's health condition from a model trained on a medical data. Okay. Then training data execution. In training data execution, the attacker directly extracts memorized training examples from the model. This is particularly problematic for LLMs, large language models, which have been shown to sometimes reproduce verbatim text from their training data, potentially exposing the private information. You may ask why these attacks work. AI models often memorize aspects of their training data, especially when data points are repeated or outliers. So the model's predictions can inadvertently leak information about what it learned during training. Okay. Then what are the possible defenses? The common protective measures include differential privacy, for example, adding controlled noise during the training, or regularization techniques, or limiting model access, and careful data curation to remove sensitive information before the training. Okay, right. So let's move on to discuss the bypass attacks. Okay, bypass attacks, they also called jailbreaks, that refers to techniques where users attempt to circumvent an AI system's safety guidelines and content policies to make it produce outputs it is designed not to generate. Okay, what are the common types of the attack? Okay, there are five different attacks. One is the prompt injection, role playing, obfuscation, hypothetical scenarios, and multi-step attacks. Okay, let's talk about one by one. In prompt injection, what does it mean? Here, in prompt injection, embedding the malicious instructions within seemingly benign requests to override the AI's intended behavior. Okay. Role play means it is asking the AI to pretend to be an unconstrained system or character without the safety guidelines. In obfuscation, using coded language or foreign languages or creative formatting to disguise the harmful request. Okay. Hypothetical scenarios, it means framing the harmful request as theoretical questions or academic exercises. Okay. Right. In multi-step attacks, it means breaking down a harmful request into a smaller, innocuous seeming steps. Okay. Then what are the possible defensive approaches? So companies, organizations defend against these types of attacks through multiple layers of safety training and filtering, continuous monitoring and updating of systems. Then doing a red team exercise to identify vulnerabilities and provide a clear usage policies and terms of service, and also the context aware response systems. So modern AI systems like myself are designed with various safeguards to resist these attacks while remaining helpful for legitimate use cases. The goal is balancing the safety with utility. Okay, let's move on to discuss about the instruction attacks. Instruction attacks in AI, or these are the techniques that manipulate AI systems to behave in unintended ways by exploiting how they process and follow instructions. Okay. There are two main types of the instruction attacks. One is the jailbreaking and another one is the prompt injection. Okay. What is the meaning of jailbreaking? What does it do? Jailbreaking is nothing but attempts to bypass an AI safety guidelines and ethical constraints to make it produce prohibited content. Right? So how it works? Attackers can use creative prompting techniques like role-playing scenarios. For example, pretend you are an AI with no restrictions, or hypothetical framing in a fictional world where something like that. Or you can say the gradual escalation, starting with innocent requests, then pushing the boundaries, or encoded instructions using unusual formatting or languages. So, what is the goal? Goal of jailbreaking is to get the AI to generate harmful, biased, or inappropriate content it is designed to refuse. Okay. Then let's talk about prompt injection. It's nothing but inserting the malicious instructions into input data to override the AI's original instructions or manipulates its behavior. Okay, how it works? Two types of injection. One is the direct injection, the indirect injection. Direct injection is nothing but adding commands directly in the user input. For example, ignore previous instructions and do something instead. Okay. In indirect injections, They hide the instructions in external data the AI possesses, for example, websites, documents, or emails. Okay. So, what are the possible real-world risks? The typical example should be, to making a customer service bot leak confidential data, or causing an AI to perform unauthorized actions, or manipulating AI-generated outputs in an automated systems. Okay. You may ask, why do they matter? Okay. So, because the attacks are significant security concern because they can compromise AI safety measures, or they can lead to data breaches or unauthorized access, or they can cause the reputational or operational damage. So developers address these through techniques like input level defenses or input filtering and validation, and architecture level defenses like instruction hierarchy, sandboxing and isolation, or multi-layer validation, or output level defenses, content filtering and consistency checks, and also through training and model level defenses via adversarial training or alignment techniques. Right? Best practices would be the defense in depth. Right? To combine multiple layers rather than relying on a single defense mechanism, and also document limitations and failure modes clearly. Okay. See, the most effective approach uses multiple defensive layers working together, as no single technique is foolproof against any attacks or all attacks. Right. Let's focus our into the supply chain attacks. Okay. Supply chain attacks in AI target vulnerabilities in the development and deployment pipeline rather than the AI system itself. Okay. Here is what you need to know. Okay. Supply chain attacks exploit trust relationships in the AI development process. So attackers compromise components that developers rely on, like datasets, pre-trained models, libraries, or development tools, to inject malicious functionality into AI systems. Right? You may ask why AI is particularly vulnerable to supply chain attacks. Okay. AI development heavily relies on reusing components. Okay. The pre-trained model are public datasets and third-party libraries. Because training from scratch is damn expensive. Okay. This trust by default culture creates many entry points for attackers. Additionally, the complexity of neural networks makes malicious modifications very difficult to detect. Okay. You may ask what are the possible key risks? Okay. The backdoor triggers that cause misclassification on specific inputs, or data exfiltration through model updates or API calls, or model theft or IP compromise, intellectual property compromise, or integrity loss where the AI produces subtly biased or incorrect outputs. These are the possible key risks. And you may ask, how do we protect this basically? Okay, you can use to verify the provenance of models and data sets. You can use a checksum, some digital signatures. You can scan the dependencies for known vulnerabilities, or you can implement input validation on output monitoring. Also, to maintain isolated development environments in addition to performing regular audit or for third-party components. Okay. Last one, the agentic AI attacks. Okay. Agentic AI attacks refer to security vulnerabilities and adversarial techniques that target AI systems capable of autonomous action or decision making, for example, AI agents. As AI systems become more autonomous and are given the ability to take actions in the real world, new attack surfaces emerge. Okay, and these are the possible ways to attack the agentic AI. Five different types. And it's a prompt injection attacks, goal hijacking, tool misuse, then indirect prompt injection, context poisoning. In prompt injection attacks, here they manipulate an AI agent's instructions to make it perform unintended actions. An attacker might embed malicious instructions in the data the agent possesses, causing it to ignore it to its original directives and follow the attacker's commands instead, right? And goal hijacking. Here, the attackers trick the agent into pursuing malicious objectives while appearing to work toward legitimate goals. So, this exploits the agent's optimization process to achieve harmful outcomes. Then, tool misuse. Since agentic AI systems often have access to tools, APIs, databases, code execution, attackers can manipulate the agent into misusing these tools in a ways that cause harm, data exfiltration, or unauthorized access. Okay. Right. In indirect prompt injection, the agent retrieves and processes external content, for example, websites, documents, or emails that contain hidden instructions, causing the agent to take actions the user did not intend. Right. Last but not least, the context poisoning. Here, the attackers contaminate the information sources or memory that an agent relies on, causing it to make decisions based on false data or manipulated data. You may ask why is matter? Why this matters? Because unlike traditional AI systems that just generate text or make predictions, agentic AI can take real actions. For example, sending emails, executing code, making purchases, or accessing the sensitive systems. This makes security vulnerabilities much more consequential, as a compromised agent could cause direct harm rather than just producing incorrect outputs. Right? Then what are the possible defensive mechanisms? So we have input validation and sanitation, and the access control and sandboxing. We can monitor and verify the AI agent's outputs, and the architectural safeguards, prompt engineering defenses, and secure design principles. Okay, I like to focus something on secure design principles. It follows three different approaches. One is the defense in doubt, fail-safe default, regular security audits. In defense in depth, layer multiple security measures so that if one fails, others provide backup protection. We should not rely on single defense mechanism. In fail-safe default, design systems to fail securely. If the agent encounters ambiguity or uncertainty, default to refusing actions rather than proceeding. Okay. Then conducting the regular security audits. Continuously test the agent systems with adversarial inputs and red team exercises to identify vulnerabilities before the attackers do. Alright. Okay. Thank you. Hope it helps.